cats and kittens. Nana boo boo.
How can I factor quadratics in order to find solutions, which are called roots, x-intercepts, and zeros?
No, they're not.
Yes, they are.
No, they're not.
All right, 2x. So here's an example of an already factored quadratic and how we can solve it to find the root. So we solve it by having these two factors, 2x plus 3 times x minus 1 equals 0. And that's going to give us when the parabola crosses the x-axis.
No.
Then you set each one the rule of factors equal to 0. I can't even think. All right, sorry. The zero factor property says that if one factor is equal to 0, the whole thing's equal to 0. So I set both factors equal to 0. 2x plus 3 equals 0 and x minus 1 equals 0. I then use algebraic steps to solve for x, and I get two x values. Those are your roots. Those are your x-intercepts. Those are your solutions. Okay? Called your zeros. This is the only time we're going to go through this. I'm going to get every other equation to this point, except the last one I'll take all the way through. To this point, and then I'll assume that you'll be able to do this. All right. This is one of the easier examples you're going to have, and we want to, as we move away from using the algebra tiles, how do I think about solving quadratics to factor them, right? That's the hardest part about this, is the thinking, the thought process that goes behind it. We'll watch other videos in class that go over how to do this. Hopefully we'll explain it slightly differently than I do, and that will give you a better perspective. But basically, if we have x squared plus 3x minus 40, we set that equal to 0. And you have to know that m plus n, we're going to come up with an m and an n term, right? And m plus n needs to equal 3, or your b, and m times n needs to equal the c. And we have to figure out what m and n are. And once we do that, they become the other terms in the factors. This part here only works when your x coefficient is 1. So when your a is 1, then we can look at this, okay? So in this case, I looked and I just tested some numbers. I said, okay, what are the factors of 40? I said 4 times 10, so I could make it negative 4 times 10. And then I could do negative 4 plus 10, and that would equal positive 6, which means that this wouldn't work. So these ones wouldn't work. So my next guess was I did 5 times 8. And then I thought, okay, so the lower number, in order to get a positive 3, I need to make it so it's negative 5 plus 8, and that would equal positive 3. And negative 5 times 8 would equal negative 40. So 5 and 8 would be my m and n numbers. And you can, once you get the hang of this, you can take the shortcut right down to this step, where once you figure out the m and n values, and I'm arbitrarily calling them m and n. That's not what they're called necessarily. But anyways, once you figure out those two numbers, the 5 and the 8, you can do, or negative 5, you do x minus 5, or x plus negative 5, and x plus 8, multiply those two factors together. That will give you this quadratic. Why does that work? Here's why it works, and this middle part here in red is very important to understand as we get to spots where our coefficient is greater than 1. So if we do x, once we get to 5 and 8, if we replace 3x with x squared minus 5x plus 8x, so we replace 3x with minus 5x plus 8x. If you combine those two like terms, you get 3x, but we're replacing it with an equivalent expression, minus 40. I then put parentheses around the first two terms and the last two terms. When you do that, you can group them and pull out a factor. So these first two, x squared minus 5x, I can pull out a factor of x. X times x minus 5 equals x squared minus 5x. So now I can replace this. This 8x minus 40, I can pull out a common factor of 8. 8 times x minus 5. Now I've created an expression with, again, another common factor of x minus 5. So I can take the x minus 5, pull that out of this expression, put it over here, leave me with just x plus 8. So if you took this x minus 5 out, right, you'd be just left with x plus 8. And then you do x minus 5 times x plus 8. All this is always staying equal to 0. So I end up with these two factors that I said down here. Again, x plus one term, x plus the other, and because it's negative 5. All right. This is one of the more challenging examples we have. It's going to take me a couple whiteboards of work to kind of get through the whole thing. This is the case where I have a coefficient of x that is greater than 1. So the first thing I would try to look to do is to try to get that coefficient to 1 by removing a common factor, such as I could say, ideally, if I could take out a factor of -4, that would be great. You can't, though, because -4 doesn't divide easily into -6 or 18. I can take out a factor of -2, which might help to make this easier. So I just divide everything by -2, leaves me with 2x squared plus 3x minus 9 equals 0. Now the zero property of the zero factor property tells me that one of these two factors has to equal 0. I know it's not -2, so I know that 2x squared plus 3x minus 9 would equal 0. And that's what I want to figure out. Now, the difference here is instead of trying to figure out what factors of -9 add up, what m and n values for 9, what are the factors of -9 that add up to +3, I now actually have to multiply 2 times -9. You multiply your a value times your c value, and that equals -18. Now I have to say what factors of -18 would add up to +3. In this case, the larger I'm going to have one negative and one positive factor because -18. So one factor will be negative, one will be positive. I know that the larger factor has to be positive because I end with a positive number. So when I look at the factors, I have 1 and 18, right? Well, 1 has to be negative and 18 to be positive. 1 plus 18 equals -1 plus 18 equals 17. So that's not it. So then I can try the next set. I could say -2 times 9. Well, -2 plus 9 equals +7, not +3. So let's go up to 3. -3 times 6 equals 18. Now let's add them together. -3 plus 6 is +3. So these two factors work. What I do now is I now go down here and I set up factors. Or I can actually just go through and set this up and pull out factors like I did for the other one. So let's go through that process. I'll change colors here. Now that I have this 3, -3 and 6 as my m and n values, so to speak, I can replace 3x with -3x plus 6x. So I have 2x squared minus 3x plus 6x. This is equivalent to 3x. I'm just replacing it. Minus 9 equals 0. I can group my first two terms and pull out a common factor, and group my last two terms and pull out a common factor. So the common factor of the first two terms would be x. X times 2x minus 3, right? Plus, and this common factor would actually be 3. 3 times 2x, -9 divided by 3 is going to be -3, minus 3 equals 0. And you can see what I ended up with is two factors. When I pull them out, these two are the same. So I can now pull that out as a factor and say 2x minus 3 times, and I'm left with x plus 3. X plus 3. And now I'm left with two factors. Note, you can't just take a shortcut here and skip once you have these. 2x minus 3 times 2x plus 3. Let's work this out and see if this equals the original quadratic. So I'm going to write this down to see if these factors will go back to the original. And the original actually is going to be 2x squared plus 3x minus 9. So that's what we want to try to get to. All right. So 2x minus 3 times x plus 3. 2x times x is 2x squared. 2x times positive 3 is going to be positive 6x. Negative 3 times x is negative 3x. Negative 3 times positive 3 is negative 9. I combine these like terms, 2x squared plus 3x minus 9. I go back, that is the original simplified version of this 0. So I would be able to get that, so these factors are correct, all right? I would just multiply them by negative 2, get back to the original quadratic. Now I set each one equal to 0 to figure out the actual roots or solution. 2x minus 3 equals 0, and x plus 3 equals 0. Subtract 3 from this one, x is going to equal negative 3, or no, yeah, right, I got plus 3. All right, just double checking, I thought I made a mistake. Now I add 3 to both sides here. I have 2x equals 3, divide by 2, x equals 3/2, or 1.5. All right, and that is how I can factor quadratics in order to find solutions, roots, x-intercepts, and zeros. Remember, this was fast. You're going to want to watch this again or watch other videos to help you master this skill along with practice.